Lesson 1 of Chapter 2 is on power and radical functions. So the entire Chapter 2 is going to be focused on a few different types of functions, and one of them is going to be polynomial functions. We're going to get to that soon. But on this lesson, we're just going to focus on, for right now, power functions, and we'll also get to radical functions. So I want to talk to you about a monomial function. You guys have heard the prefix mono before. Mono means that there's only one term. And so every one of your functions is going to look like this. Some examples might be f of x equals 3x to the 5th. Or maybe it might be f of x equals negative 4x to the 6th. So there's just going to be one term. There's going to be a number where the a is, and the a is what we call the leading coefficient. And there's going to be a number where the n is. The n is what we call the exponent. You're going to look at those two things to determine what the graph is going to look like for this monomial function. Now, I use some terminology that's not formal mathematics terminology, but when the exponent is an even number, then it's either going to look like this, what I call a touchdown guy, or it's going to look like this, what I call a gorilla guy. Now that's when the exponent is even. What's going to determine if it's going to be a touchdown guy like I have circled in red or a gorilla guy like I have circled in green is going to be the leading coefficient. If it's a positive leading coefficient, it's going to be a touchdown guy like you can see encircled in red. And if it's got a negative lead coefficient, it's going to be a gorilla guy like I have circled in green. Now in the last chapter we talked about all these different qualities of functions, so domain, range, intercepts, continuity, symmetry, decreasing and increasing behavior, and end behavior. So you can see the specifics for every function that has an even exponent with a positive lead coefficient is listed below the red circle, and all the characteristics of a graph that has an even exponent with a negative lead coefficient are listed below the green circle. Now we also have what I call a disco guy Randy, and that's this. We also have what I call a disco guy Larry, and that would look like this. So we have these types of graphs when we've got not an even exponent but an odd exponent. So if it's an odd number and a positive lead coefficient, it's going to be a disco guy Randy like you can see circled in red. And if the exponent is odd and leading coefficient is negative, it's going to be a graph like what I call a disco guy Larry, circled in green. The characteristics for those two types of functions are listed below. And so here's the kind of problems you're going to be doing. It's going to say to graph and analyze each function, describe the domain, range, intercepts, end behavior, continuity, where the function is increasing and decreasing. So I've got the graph already drawn for this particular function. This is what I call a touchdown guy because both ends are going up. And so to analyze it, the domain would be all real numbers. The range for this function would be from 0 to infinity. The intercepts, looks like it touches the x-axis and crosses the y-axis at 0. So I'm just going to say that the intercept is at 0, 0. The end behavior needs to be written correctly, and it gets written like this. So this is describing the left end, which happens to be going up. This is describing the right end, which happens to be going up as well. So that's how we'd write the end behavior. This is a continuous function. And this function is increasing from 0 to infinity. That's the right half of this graph. This graph is decreasing from negative infinity to 0. That's the left half of this graph. And so that's analyzing this function. Let's do another one. This particular one is what I call a disco guy Larry. So the domain of this function is all real numbers. The range is also all real numbers. Intercepts happen to be at 0, 0 again. And behavior can see here that the left side is going up, and then you can see that the right side is going down. So there's your end behavior. This is a continuous function, and this function is increasing nowhere. As you go left to right, this function is always decreasing, so it's decreasing entirely on its domain. Here's another example. Now we're going to start talking about when you have negative exponents. When you have negative exponents, then the graph's going to look different. So what I need you guys to understand is that 3x to the negative 2 is equivalent to 3 over x to the second. So when you get a negative exponent, you can take that variable, the x to the negative 2, you can move it to the denominator, and it becomes a positive 2. So the domain of this function is all real numbers except for 0. The range of this function is greater than 0. Intercepts, this has no intercepts. There's no x or y intercepts. The end behavior, you can see that if you go to the left, you're going to get closer and closer to 0. And if you go to the right, you're going to get closer and closer to 0 as well. This is a discontinuous function. The type of discontinuity is infinite discontinuity. It looks like we have the left half of this graph is increasing, and the right half of this graph is decreasing. So there's the characteristics of that particular function. Last one. Again, we got a negative exponent. This time it's a negative odd exponent. So I need you to realize that this function is the same thing as negative 3 over 4x to the 5th. And so our domain is all numbers except for 0 again. Our range is the same thing, all numbers except for 0. Intercepts. We have no x and no y intercepts. Our end behavior, as you go really far to the left, this graph is getting closer to 0. And as you go really far to the right, this graph is getting closer to 0. This is a discontinuous function. Again, it is an infinite discontinuity at 0. And it looks like we have increasing behavior from negative infinity to 0 and also from 0 to infinity. We don't have any decreasing behavior. So this is analyzing monomial functions. And the last one I want to do is talking about this graph. You can see if you have a fractional exponent, your graph is going to look different. So this is the same thing as the square root of x to the 5th. So the top number of that exponent tells you your exponent, the bottom number tells you your root. This particular one has to be considered as a square root. So your domain on this is from 0 to infinity. Your range is also from 0 to infinity. Intercepts, this touches the x and y axis at 0. The end behavior, if you go really far to the right, this graph goes up, and there isn't a left end behavior, so you just write the right end. This is a continuous function. And then this function is increasing from 0 to infinity, and it is decreasing nowhere. And last one, we've got a negative fractional exponent, so this would be the same thing as 6 over the third root of x to the second. And so our domain for this function would be all numbers except for 0. Our range for this function would be numbers greater than 0. intercepts, we have none. End behavior, you can see that if you go really far to the left, it's getting closer and closer to 0. And also, if you go really far to the right, it's getting closer and closer to 0. This is increasing on the left-hand side, so from negative infinity to 0. And it is decreasing from 0 to infinity, the right-hand side of the graph. So that's an introduction on analyzing graphs of monomial functions. We talked about your exponent being even, odd, negative, and also a fraction. And you also need to pay attention to the leading coefficient. That's going to determine what the graph looks like. Certainly you can rely on your graphing calculator to help you look at the graphs and then figure out the different characteristics of those functions.